Welcome to Supercharging SQL Users with Jupyter Notebooks. I am Michelle Ufford, the CEO of a newly formed company called Notable, and I want to share with you today some of the things that we did at Netflix and that we've seen at other large companies to empower SQL users within the notebook. Now, typically during one of these talks, I would invite you to come ask any questions you have afterwards, but given that this is virtual, I'm instead inviting you to ask any questions you have on Twitter. Also, we're going to be covering a lot of content today, so don't worry about trying to keep track or take notes. All of this will be available online, and we'll also have tons of links to different useful resources at the end of the deck. I know what some of you might be thinking. SQL, do we really need to enable SQL in the notebook? I mean, what self-respecting data scientist would choose SQL when you've got perfectly good Python available, right? And the truth is, most of the data scientists I know do prefer Python and pandas. But if you go outside of that data scientist sphere, you'll find that there is a much larger audience of SQL users. In fact, SQL is still the #1 language in the world for working with data. And I've had lots of people ask me, what about NoSQL and all of these new big data technologies that are coming out? Well, what we are doing instead of getting rid of SQL is really adapting those technologies to work with SQL. So SQL, even though it's been around for 33 years, doesn't have an end in sight. You don't have to take my word for it. In Stack Overflow's most recent developer survey, 56.9% of respondents have familiarity with SQL, whereas only 41.6% do with Python. And what's interesting here is that we have this really robust support for Python inside of the notebook, but we also have really good support for things like R and Scala and Julia. But we don't have very good support for SQL. So I think it's time that we give those SQL users a little love in the notebook too. But there are some very good reasons why we do not have better SQL support in the notebook. First and foremost, SQL is not a programming language. It is a query language, which means that it has different constructs and ideas of data definition language and manipulation language, transactional language, control language, and it doesn't have the same building blocks that you could build a kernel on like you would with Python. There are other challenges with SQL as well. One of the big ones is that there are so many different dialects. I mean, every single system seems to have its own flavor. So you've got ANSI SQL and T-SQL and PL SQL, and now you've got Hive and Presto. You've got lots of different SQL languages, and they're each different enough just to be annoying. There is also a broad spectrum of users. So on the one end of the spectrum, you have your more technical users, such as your data scientists or your software engineers. But on the other end of the spectrum, you have less technical users, such as your data analyst and your business analyst. And these less technical users might not even know any programming languages at all. SQL might be the only language they know. And so for those users, doing some of those tasks that you would have to do to be able to work with SQL, such as writing Python code to connect to databases or authenticate or do any sort of conversions, all of those things are very confusing and challenging for those users and really present a pretty big barrier to entry. So we are going to introduce a 3-tier action plan that is going to walk you through some of the things you can do to make SQL easier for your users. We're going to start with this foundation layer. The foundation layer is what we're going to be building upon in our subsequent layers, but it also provides some of the easiest low-hanging fruit for you to tackle first. The first thing we need is a hosted notebook environment. If you do not already have one of these, JupyterHub is a great place to get started, and there are lots of really great documentation and resources to help you. But you don't necessarily need to have JupyterHub. The goal for you at this phase is to really have that hosted notebook environment. Let's look at an example using JupyterHub. JupyterHub gives you a single centralized location. This way, your users do not have to worry about having all of those different configuration settings or being able to connect to your environment. You can set all of that information up in a single centralized place. This makes it easier for you to define and provision compute resources, to improve security, to provide environmental settings, and even to provide a consistent Docker image for your users to use. It also makes it a little bit more secure because now you're not having a whole bunch of local Jupyter instances running, which means your users are not sucking down all of that data to their local laptop. Now let's get to the fun stuff, SQL Magics. If you're not familiar with Magics, it's a concept that really originated with Python and ipython and carried over into the Jupyter project. And Magics allow you to encapsulate code into a very easy user-friendly command. Let's look at connecting to a database without SQL Magics. Your code might look something like what's on the screen. And if you're technical, this isn't that bad. It's only about 6 lines of code. It feels pretty familiar. In fact, I've seen way worse. But if you are not technical and you do not know Python or other programming languages, this can easily be overwhelming. What does an import mean? What host do I need to connect to? I don't know. What's a data frame? These are concepts that can really detract from their goal of just trying to run a query. And so you can understand that this would really pose a pretty big barrier to entry for those users. Let's try running that same command with sqlalchemy this time. sqlalchemy is a very popular and useful package that allows you to connect to a wide variety of different database systems. And you can see it has cleaned up things a bit. I have gone from my 6 lines of code now down to 4 lines. But again, if I don't know Python, this still feels a bit confusing because now we're talking about import statements and we have this concept of an engine. And then I've got my SQL statement. So again, this might be a little bit confusing and a little bit too much for those users. Now let's try running that same query, but this time with SQL Magics. The first thing we need to do is install ipython-sql. ipython-sql is a very useful package that provides SQL Magic functionality in both IPython and in Jupyter. So if I'm looking at the same code from the perspective of a SQL user who does not understand Python, the very first line, I don't know what that's doing, right? Pip install, what's that mean? I don't know, but I can kind of ignore it. Then we've got 3 lines that all reference SQL. So the second line is loading the SQL extension. I can conceptually understand that. And then we have 2 lines that are both prefaced with SQL. That first SQL line is really our connection string. Now, I might not be able to write that connection string, but if I could copy and paste that, I can conceptually understand what that's doing for me. The last line just has %SQL and our select statement. And that feels a lot more accessible to me than what we've been looking at previously. Now let's look at one of the really easy things you can do that can have a huge impact for your users: libraries. Hopefully, you have already talked to your users about which libraries they use most frequently. But if you've not, please, please, please go talk to your users. Ask them, what types of tasks are you doing on a regular basis? Or if they are using Python, what are the packages you cannot live without? What are the packages that are in almost every notebook that you create? Those are the packages you want to pre-install for your users. For data specifically, the packages on the screen are some of the most popular. Now, not for data science, because that's a whole other can of worms, but for working with data and doing basic things like data manipulation or data scraping or data retrieval, these are very useful packages. There are many different ways that you can add these libraries to your environment. We're going to walk through one of the easiest ways, which is right in your Docker image. This is also going to set the stage for some of the work that we're going to be doing a little bit later. To do this, you just edit your Docker file and you add the install commands. So in this example, we have a run conda, but it could be pip install, it could be npm, whatever your package manager is. You just want to get those libraries into your Docker image. Let's go back to that same query we've been trying to run. You can see we are now down to 3 lines of code. And we've gotten rid of that pip install. And that is actually a bigger thing than you might realize, because whenever you run that pip install, you have a whole bunch of stuff that is scrolling across the screen, which is a bit intimidating. And you also have a potential for collisions or install failures, right? So you've really eliminated that whole piece for your user. And everything that is left feels very familiar. I'm going to load my SQL extension. Yep, I can understand that. I'm going to connect to the database that I've provided the connection string for. I can also understand that. And I'm going to run my query. I can definitely understand that. So this is really an ideal place for you to get to inside of your environment. The last thing we're going to cover in this first tier are extensions. Now, if you're not familiar with Jupyter extensions, they allow you to extend the functionality of the notebook UI. This has a lot of different, very valuable uses, and there are a lot of high quality, amazing extensions out there. One word of caution though, before installing these extensions, make sure that you are checking to see who wrote this code, where did it come from, what is the quality of the code, is it well documented, and is it being actively maintained? This is really things that you want to do before you put this in a hosted notebook environment. For SQL users, one extension that could be useful is the Jupyter Lab SQL extension. This gives them a very GUI-like experience for connecting to databases, for exploring tables, running queries, and interacting with the results. So that's going to feel a lot more familiar and more like the query editors that they're probably used to. Okay, so that wraps up our first tier, our foundational tier. As we mentioned, these are some of the easiest things you can do, but they have a huge impact on your user's quality of life. Now we're going to look at the second tier. This is the integration tier, and this is usually more targeted at a large enterprise environment, but really any place that has a large number of SQL users or notebook users would probably be interested in this type of functionality. The first thing we need to do in the second tier is lock everything down. So JupyterHub does provide some security features, but those features are not enough on their own to secure the entire notebook environment. Now, again, the goal here is not necessarily to use any particular technology. What we want is a secure hosted notebook environment at the end of the day. One thing you might want to look into is the Jupyter Enterprise Gateway. The Enterprise Gateway offers several security features such as better SSL, SSH tunneling, and user impersonation. It also allows you to decouple the notebook execution from the kernel execution. So this gives you better, more granular control of your compute resources. Lastly, it allows you to define multiple images for your users. You might want to consider creating a different image for each different type of class or organization of users. The reason for this is to prevent that image bloat that can sometimes happen in these Docker images and prevent unnecessary conflicts from different dependencies that don't necessarily need to be there. There are several different ways we could set up our environment variables. We're going to look at how to do it using JupyterHub's config.yaml file. This will make any of the variables we define available to all users system-wide. In our example, we want to make the connection string information for our production data warehouse easily available. Now we're just going to add this one connection string, but in reality, you might want to also add your dev and test environments or any other database systems that your users frequently connect to. Ideally, you will have also integrated with your own internal authentication system. That way, you no longer have users having plain text username and password floating around in notebooks. Let's go back to that same query we've been trying to run and look at our code. We still have 3 lines of code, but each of these lines of code feel very accessible and comfortable to a SQL user. We're first going to load our SQL extension. I can understand that. Then we're going to connect to our production data warehouse. I definitely understand that. And then I can run my select statement. So this is really an ideal state to get to in an enterprise if you have a large number of SQL users. In fact, you could even get this down to 2 lines of code if you want to install that SQL extension for everybody. We've talked about database connection strings, but there are many other uses for these environment variables. And they will not only make life easier for your users, but they will make your life easier too. For example, you might want to put your secrets in a variable. That way you don't have them floating around in all of these notebooks. You also could put the path to an internal API. That way, if you have to make a change, you don't have to go track down all of those users and have them update that path. Or you could even set some sensible defaults for your compute resources. That way you can avoid any sort of waste and overallocation. Okay, templates. Templates are another one of those things that are exceedingly simple in concept and yet unbelievably powerful in practice. In fact, templates are what enabled Netflix to integrate Jupyter Notebooks with the rest of the Netflix data platform. So how did we do it? Well, first we had to create Papermill. Papermill is an open source library that allows you to parameterize a notebook and run it in a headless state. A template is just like any other Jupyter notebook, but it has one cell that has a parameters tag. And within that cell, you have one or more variables that you've defined with some default values. Papermill will take your input or your source notebook. It will create a copy of it, substitute any parameters that you pass at runtime. And if you don't pass any, it will default to whatever's in the notebook, execute the notebook, and write it out to disk. In our case, we made sure that the destination of that notebook would be someplace that was immutable. This allowed us to now have an immutable record of any execution of that template. So what does a template actually look like? Well, in this example, our first cell is our parameter cell. You can tell because it has the parameters tag. It also has 4 variables defined. Now, each of these variables will be values that you can substitute at runtime. If you do not provide any values, it will fall back to whatever is defined here in the notebook. In our second cell, we have our SQL Magics from earlier, and we have our environment variable, and we are running a very simple select statement. In that statement, we are checking for the number of rows where a very important piece of information has not been provided. It's null. Now, this is a very common type of thing that you might run against lots of different tables inside of your environment. It might be as part of a post-deployment check or as part of an ongoing data quality validation that you would do. And so typically you would create different versions of this for every single table. In this example, we have created just one, and we can now call this over and over again with each of those different tables. This makes it way easier and more scalable inside of a large organization where you have lots of tasks that you're doing over and over and over again, and a large number of objects to do those tasks against. So how do we actually use the template? Well, one way you can use them is on an ad hoc basis. For example, you might have a data scientist who has a notebook, and she wants to run that exact same code, but over multiple parameter sets. The templates make it very easy for her to do that. But the real power of templates is in the ability to integrate them with the rest of your organization. Let's look at a couple of examples. The reason why we first started down this path was because we wanted to schedule notebooks. We wanted it easier for a data scientist to schedule their own notebook, but we found that the artifact of execution that we created for them was actually a much better experience than what we were currently giving our data engineers. So we had this idea that we would continue to have our data engineers working in their IDE, checking their code into Git, continuing to write their workflows in JSON. And when it came time to execute those jobs, we would execute it through the context of a notebook. This allowed us to have pre- and post-processing steps, all of that boilerplate around environment settings and logging and loading packages, all of those things that we would typically have to create some sort of manual template for, right? The manual templates work, but only until you have to make a change. So the first time that you want to go have everybody change the package or the URL for something, you have to go notify all of your users and ask them and stay on top of them to make changes. So it is a lot easier for them and for you to instead just use this template. And this worked extremely well for us. In fact, by the time I left, we had 150,000 jobs that were running through the context of a notebook. Another way that you can use templates is with other systems, making a call to a notebook. For example, you might have an event listener that is listening for certain security incidents. And when it finds one of those, it would make a call to a notebook that has all of your security troubleshooting scripts in it. It would execute that notebook and it would send the results to your SOC. And that would give your security folks a jump start on trying to understand what is going on there. We've talked about how you can leverage templates as part of your workflows or your data quality checks, but there are a surprising number of applications for these templates. For example, training. Training is one of those things where it's not important until it is. And notebooks offer a very easy and interactive way to bring people up to speed on your environment. And I'm not just talking about your data people, though it works wonderfully for them, but also your software engineers. Because if you're trying to teach them how to make a call to an API or where everything is sitting, the easiest way to do it is in an interactive executable environment. The third and final tier is customization. Now, I'm not going to lie, this is territory that few companies venture into. But if you have the need and you have a large enough environment and a large enough user base, it can often be worth the investment. Earlier, we talked about how you can leverage ipython-sql to add SQL Magics to your notebook. And this gives us a great place to start from. But in large organizations, you often have not one, but multiple different database technologies. And it can often make a lot of sense for you to create different magics for each of these. There's several reasons why. First, it provides better clarity for your users when they can very easily see which SQL dialect should they be writing in. Secondly, it allows you to pass very important environmental information directly to the kernel. And hopefully, one of your goals here is to obfuscate as much of that complexity as possible from your users. You can also allow your users to specify optional parameters at runtime. One really helpful one is changing the compute cluster. So oftentimes in large organizations, you might have different users or teams that are vying for resources. And by giving them this control, it makes everybody's lives easier. And lastly, you might want to allow them to change the amount of memory that they are using in their compute. Hopefully you've defined sensible defaults earlier, but when you're running into a large table, you can run into out of memory errors. And so you want to give them the option to be able to change that pretty easily. Up till now, we've been using SQL Magics to run our queries, but you can also create your own SQL Magics that encapsulate very common useful functionality for your users. For example, one thing that they are doing every single day, multiple times a day, is trying to find and understand data. And one of the easiest things that you could do for them is to create a custom magic that looks like something like what's on the screen here. In this example, we are just simply retrieving data from a system table that shows all of the tables in that particular database. Some of your users will already know how to do these things themselves, but many others will not. And so this is going to make their lives a lot easier. You might also want to do this or need to do it if your users do not have read access to those system tables. This way they can still get that same information they need. And here's how your users would call it. Just like the SQL Magics, they don't necessarily need to pass any parameters, but you could define them if you want to, and it will retrieve a list of the tables. Another thing that your users are constantly doing is sampling data. Now, if you're talking to a data analyst, they might just be doing a simple select star from limit 10 or 100, and that works pretty well for them. But what I've increasingly seen is people trying to randomize the data that they're getting back. So this is usually not a problem, especially if it's a small enough table. But once you get into large tables, it can become very problematic because what they are doing, and they don't even realize, is essentially scanning the entire table to retrieve that randomized sample. So you can actually make their lives easier, and you can also avoid wasting any sort of compute resources, and they can get their queries back faster if you specify a SQL magic that is always checking for the most recent partition as part of that data sampling. Customizing your UI. This is going to be the last thing we talk about today. And I'm going to be completely candid with you that this is a non-trivial undertaking. However, in the right circumstances, with a large enough environment, with a large enough number of users, and with hopefully some front-end developer resources available, it can make sense for you to make those investments. Let's start by looking at a very simple example of a custom UI component. In this example, we're returning data from a query, but instead of seeing it in your default tabular view, we are seeing it in something that's a little bit more dynamic and interactive. It offers pagination, sorting, filtering, and generally just is a better quality of life experience for your users. Now, I'd like to say that most of the UI components I've seen have kind of fit this structure, but the reality is that most of the investments I've seen in this space have been around more custom business logic. So I cannot show you an example of one of those, but I can talk about it. One example we had was a component that would render the box art, the title metadata, and the recent performance of that title for every title in a data set. And that would be the kind of thing that you could see would have broad applicability and usefulness and might be worth the investment. Now, if you decide you do want to explore this space, you don't have to start from scratch. In fact, I suggest you actually start by looking at Interact. Interact is an open source project that provides an alternate UI for Jupyter notebooks. They also have a very pluggable component library that could be a useful place to get started. And actually, that is where we got that screenshot for that table you just looked at. Another library that could possibly be helpful is Blueprint.js. This was put out by Palantir and provides a very data-focused set of components. And that concludes my talk. Hopefully, you are walking away with some ideas on how you can make life a little easier for your SQL users, and maybe even a little easier for yourself too. As I mentioned, links to everything we discussed are at the end of this deck, and those slides are already available online too. If you have any questions, please reach out to us on Twitter. We are happy to answer any questions you have. We're also in the process of building a new collaborative notebook with a native SQL experience. If you have any thoughts or input on that, we would love to hear from you. Thank you.